Okay. So I actually made a change. Instead of just returning W and B individually, I put them in a dictionary where W represents our W and capital B represents our B. And I'm just returning that dictionary, and it's just cleaner. And one way we can access that is we can say I is equal to that function with the passed in parameter, and we can actually access the dictionary from that variable. So I can say print I, right? This function's B, the dictionary. So let me show you. If I put B at like 9 and then I print B, you see we'll get 9. So that's something to know, something I'm gonna do a lot. So now I'm gonna say def propagate, right? We're gonna pretty much backwards propagate here. So I'm gonna pass in x, y, w, and b. So if you remember what I said from the last video, so m is gonna equal to x, x shape, um, and actually we're gonna get the first one because it's gonna be a 2D array, and so one is actually the how many examples we have, right? 0 is how many matrices, I believe, right? Because this is a 2D array. So our second representation in the dot shape function is going to be how many examples we have. If you don't know, play around with that. So then A is going to equal to our sigmoid. And remember, our sigmoid takes in z as an argument, and it turns that into a negative z. So our sigmoid function is going to be numpy dot. So the dot product, if you remember, I said w transpose, and actually, sorry, w transpose and x, and we're gonna add that with our b, right? And the reason we take the transpose here is because, let me put some spaces here. Okay. So reason we take W transpose, if you don't know linear algebra or are just confused, is because W is a column vector, right? If you remember, it's gonna be a something by one vector, or actually matrix, whatever. I'll just keep it vector, right? So it's gonna be some column by one row, and since W shape is actually determined by X shape, right? So since W column uh, examples is equal to X is equal to number of examples in X, and X is also a column vector, so that's going to be two column vectors being multiplied, and we cannot multiply two column vectors. And we have to take the transpose of W in order to do this calculation. So once that's done, I'm going to say cost is equal to what I showed earlier, 1 divided by m, right? And if you remember, m is the number of training examples we have, right? And I'm going to explain why we do 1 over m in a second. So 1, actually I'm going to say numpy multiply, and I'm going to say 1 over m, and I forgot to open another parentheses here. 1 over m times our negative dot product of y and the log of a, or sorry, lowercase a. Okay, so it's complaining it's not closed. So I'm just doing the cos function where cos is equal to 1 over m times the sum of I forgot. I have it right here. Wait, give me a second. So it's 1 over m times the sum of negative y times the log of y um, plus 1 minus y times the log of 1 minus y pred. And sorry, this should be y pred, which is just our y prediction. So I'm just doing that right here. So we're multiplying 1 over m by the dot product, the negative dot product of our y, and actually this should be here, but you get the point. So the dot product of our y and the natural log of our prediction, and our prediction is this into the sigmoid function, right? So I'm literally just doing that right here. So the dot product of y by the log of our prediction, and even I'm confused by how this looks. Okay, pretty sure we just do plus, wait, plus 1 minus y, or actually it's going to be plus the dot product of 1 minus y times the log of 1 minus a, or sorry, numpy log. And I'm honestly not sure if this is right. So the negative y times numpy log, numpy log of a. Sorry, this should be minus because negative times a positive is a negative. So minus the dot product of 1 minus y, and I don't know why there's a parentheses there. So 1 minus y times the numpy log of a minus 1 minus a. Okay, this should be correct. So now I'm gonna say derivative of w, right, is equal to numpy dot multiply our 1 over m again, and I forgot to open a parentheses again. So 1 over m by the dot product of our x by our a minus our y, and we have to take the transpose, right, because two column vectors again. So let me explain this. If you remember, derivative of w is actually it's actually just all of our x's times the sum of all of our derivative of z's, right? Where derivative of z is equal to a minus y, right? So, and sorry, I forgot. 1 over m times all of our x's, so 1 over m times all of our x's times the derivative of z, a minus y. So and let me actually explain this up here. So reason we do I forgot what I was going to explain. Oh yeah, the reason we do 1 over m, if you're not familiar with gradient descent, is because we want to reduce the cost, the average cost over our entire data set, every single example, right? And dividing by 1 over m ensures we are getting the average loss to reduce. Alright, I hope that makes sense. It was even tricky for me to understand. And I think this should be correct. Yeah. And then our derivative of b is obviously just going to be the sum of all of our derivative of z's, which is just a minus y. And then I'm going to put this all in a dictionary. I'm going to say cost. Wait, I'm going to say. I'm going to say. Wait. I actually don't know what to call these ones. I guess I'll just say derivatives. You know what? I'll just say. This is terrible. You know, I'm just gonna return cost, derivative of w and wb instead of putting it in a dictionary. Or maybe I'll say just derivatives cost. Terrible naming. You would probably usually put this. You would put the cost in your derivatives in a separate function, but I don't think that's really necessary for logistic regression. Oh, and I forgot. Sorry, I completely forgot. NumPy multiply. Why did I not put NumPy not multiply 1 over m? Okay, should be correct. So, you know what? I'm just gonna say derivatives. Why am I? Whatever. I'm just gonna forget about that. So I'm gonna say derivative of w, derivative of w, um, derivative of b, derivative of b, and actually up here I'm gonna say cost, cost. Okay, and that's gonna be our dictionary. I'm gonna try to run this and see if I get any errors. Wait a minute, I forgot. Okay, so alright, I'm gonna say x. I'm gonna say training set. This is gonna be our x variables. I'm gonna make a NumPy array of a 2D array. If you remember, W shape is a 2D array, so I'm gonna just make this a 2D array. I'm gonna pass in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And training set values is equal to, I was gonna say training set y is equal to NumPy array. And I'm gonna pass in 0, 0. If you remember, these are our answers. Wait, put 7 here. That's 10 here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just another one there. And then I'm gonna W and B. Okay. Wait a minute. Yeah, okay. So now I'm gonna say W and B is equal to actually I'm gonna say W is equal to initialize parameters, and I'm gonna pass in training set dot shape. I'm gonna say wait, W is equal to wait, we'll try it. Okay. And then B wait a minute, what am I doing? Yeah, so W is equal to that shape. Wait a minute. Nope. Not shape. So W is equal to initialize parameters. I pass in that. Uh, 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 uh. Sorry. Okay. The video was getting long, so I had to pause it and fix the errors. So there was actually a problem here. If you go back in your code and check, I forgot to put a parentheses here and a comma between the what's it called? A comma between the 1 minus y and that. Sorry. Okay. Also, this is how I did this one. I passed in our training set. Actually, let me call this X so it's not confusing. So I passed in the shape. Then it turns the W column shape to our X column shape. Pretty simple. And that's multiplied by 0.01, whatever. A is equal to the sigmoid, and then I fixed the cost, and I don't know why I'm talking about that. And then after I gave W its shape, I retrieved W and B. What's it called? Which gives us the value of W and B after W is randomly initialized and B is 0. And then I called the propagate function and passed in training set X, training set Y, and this is just temporary. And I passed in W after it's retrieved and B after it's retrieved, and after I print that, okay, a random error. Line 1. Oh, what? Okay. I have no idea what that. Oh, that was the other file. Okay. So after I print it, we get our cost, we get our derivatives of. We get our cost and then the derivative of both our variables.